So in learning goal 52, we're going to be taking a look at creating context for a linear equation. Now, this really comes into play when we are given a linear equation and we want to kind of come up with some sort of way of describing it. Now, often we're going to go backwards, and we're going to take a look at that next time. But for this one here, we're going to go through just creating some context, coming up with some questions that we may have. So in math class, linear equations are often shown strictly for their ability to solve problems without any context. Now, this is what we've been doing up until now. We've been going through how do we come up with an answer to some sort of linear equation. Okay, what is x? What is y? What can we how can we come up with that? There's no context to it. It's just come up with the answer. Now, outside of class, context is always added to a problem. Okay, strictly using numbers and letters or variables, no context is just really what we would consider to be a math class problem. Now, a contextual problem can be solved using a linear equation. Often, a linear equation is connected, often a linear equation can also be connected to a contextual problem. Today's lesson is going to be about coming up with those types of questions which are represented by a linear equation. But I give you a linear equation, and you got to come up with the question. Now it's going to take a little bit of thinking. It's going to take a little bit of creativity at times. Sometimes the creativity you come up with could vary from person to person, but we're going to try to do our best in coming up with these problems. Now, the first thing that we do whenever we have a problem is we need to define variables. Okay, we need to understand what our variables are. So, a variable, as we know it, is a placeholder for a number, which may be unknown. So we might have an unknown, or we're going to have an unknown number, which is a part of our question, and so that's what a variable is often going to be used for. Okay, it also could have multiple values. See if we can get that in here. Or is a dependent, or sorry, is dependent on some other factor. Okay. Now that's usually the other variable. Now sometimes we'll usually kind of take our y value is dependent on x. So as x gets bigger, y is going to get either bigger or smaller, okay, depending on the way that the equation works. Okay? So it could be dependent on that. It could also just be a placeholder for a number because we're not so sure what it is at that point. Or it might be that there are a whole bunch of values which could be the answer. It's all depend, yeah, it could be a whole bunch of different solutions. When context is a part of a problem, the variables will stand for something. Okay. Now, when we talk about context, we are defining a variable shows what it stands for. So we're going to make sure to define our variable. We're going to make sure to come up with what is that value. What does that value represent, or what is that variable going to represent? So that's the important thing when it comes to defining our variables, and we're always going to make sure that we do that. Okay, we're always going to make sure that we do that. Now, how do we create a contextual problem which can be solved using this equation right here? This equation right here, we have two numbers being added together, x and y, and they equal to 23. So we can probably come up with some examples like 10 and 13, or 15 and 8, or 1 and 22, or -5 and +28. Those all work. Okay, those would be values that work in this case. But to come up with an actual problem that is defined by that is maybe a little bit more difficult. So the first thing that we want to do is we need to think up some sort of problem which could be solved using a linear equation. So we're going to think up some sort of problem which could be solved using a linear equation. Now in this case here we have two numbers that add to be 23, and so the problem that I'm going to use here is I'm going to say that the number of students in a class is equal to 23. And number of students equal in a class is equal to 23. Now, this problem, okay, will have two, a little farther, two different variables which can be defined. Now, in this case here, we got to think of two different things which add up to be 23 students. That's at least what I'm gonna go with. Okay, so we got to define what those two variables are going to be. So define what each variable represents. And I'm just going to slide this back into the line. Okay, x, and I'm going to put this in here as soon as I can. X is going to equal the number of male students in class. Okay, so that's going to be the number of male students in class. Y is going to equal the number of female students in class. There we go. Okay, so it's the number of male students in class and the number of female students in class. When we add that together, we should get 23. Okay, so that's the way that I'm going to recognize these variables in here. Now, when you're making your definition or when you're defining your variables, you need to be specific in your definitions. So don't just say male students. Okay. Well, we want to know the number of male students. Okay, that's what we're actually representing. It's the number of male students. It's not just male students, because there could be a whole bunch of other ways of defining that as well. Now, the final thing that we're going to do, and we kind of did this already at the start, we write out the problem using words. Okay, so here I did the number of students in class is equal to 23. And what I could actually put that as, and I'm going to rewrite it here a little bit. This is kind of my thought process that I was coming up with, is the combined male and female students in class is 23, or something along those lines. Okay, so it does kind of use my two variables here, my combined male and female students in class. Okay, so again, X number of male students, Y is the number of female students. We've come up with a problem that could be solved using this equation.